Hi guys, today we're going to be talking about inverse of a square matrix. We are going to be finding the inverse of a square matrix by using a calculator. But before we do that, we have to look at the identity matrix. Okay, so identity matrix, okay, or you can say multiplicative identity. It's hard for me to say. Okay, the identity matrix for square matrices. Okay, so we only have identity matrices for square matrices only. What does that look like? So I'm going to show you by example. So let's just say that we have a square matrix of order 2. So square matrix, you know, the rows and columns are the same. Order 2, that's code for 2 by 2 matrix. What does the identity matrix for a 2 by 2 matrix look like, or a square matrix of order 2? The identity matrix for such a square matrix is the matrix where we have diagonals. We have a 1 on the diagonals and then 0 elsewhere. Okay, that color wasn't really hot. Okay, so the identity matrix for a square matrix of order 2 or 2 by 2 matrix is the matrix where we have 1s along the diagonal and 0 elsewhere. Now, what does the identity matrix for a square matrix of order 3 look like? So square matrix of order 3, that's code for a matrix of size 3 by 3. So it's going to be the same speech. The identity matrix will have ones all the way on the diagonal. Yeah, that's also a Seki highlighter, sorry. Okay, so the identity matrix will have ones on the diagonal and then 0 elsewhere. Now, to get to the meat of this section, the inverse of a square matrix. Okay, so in order for us to have an inverse or a fighting chance, we need to have a square matrix. Okay, if there's a square matrix, then there may be an inverse. So if A is our square matrix, then the inverse is denoted by something that kind of looks like A to the -1 power. But this is the notation that we use for inverse, so that will be A inverse. Now, if we have a square matrix and the inverse exists, what has to hold true? Then the following has to hold true. The product of the matrix and its inverse needs to give us the identity matrix, and then the product going the other way around should also hold true. The product of the inverse of some matrix and its matrix should give us the identity. Now, some matrices don't have inverses, and that's okay. If a matrix doesn't have an inverse, then we're going to say that that matrix is singular. Singular is code for like we don't have an inverse. Okay, so fun problem number 1. It says use a graphing calculator to find the inverse of A and please express all values in exact form. For students, it's very tempting to round, but remember, we're always looking for exact answers and we only round if we're asked to. So let me go ahead and take out my real calculator, and then I'll take out my fake calculator, the ones where I can show you the buttons. Okay, let me get this up and running. Okay, I planned this in my head, but things are not coming out. Oh, that's dirty. Give me a sec. You would think I would check this. Oh, I can clean it. It's okay. I try my best. Okay. So how do I enter matrix A in our calculator? Okay, so we're gonna look for the matrix button. Okay, so where am I? Okay, so the matrix button, it's not a main key, it's a behind key. It's behind the x to the negative first. So we're gonna put second matrix. Okay, so it's that behind key, second matrix, which is x to the negative first. So you can pause this video and rewind it as many times as needed. So second and then matrix. Cool. Now if you haven't used this feature, then you will have like lots of blanks. Okay, but I've used it before, so I have stuff. Okay, now you are gonna edit any matrix of your liking. I don't want to get too excited, so I'm just gonna edit matrix A. So we're gonna use the side arrows to hover over to the edit tab. Okay, cool. And then you are gonna scroll down until you get to whatever matrix you want to edit. I want to edit the first matrix. I'm already at number 1, but if you want, you can use your drop down arrow. Cool. So let's go ahead, hit enter. Then we're gonna list the dimensions. So this matrix has 1, 2, 3, 3 rows and 1, 2, 3 columns. Okay. So first of all, I should establish, is there a chance that this can have an inverse? I need to verify that this is a square matrix, and it is, because the number of rows and the number of columns is the same. So let's go ahead, enter the dimensions, which is 3. So you hit enter and then 3 again. And then you notice that we have a matrix of 3 by 3 dimension, dimension 3 by 3. And then we're gonna enter the elements one row at a time. So you hit number 1 and then you hit enter, 2, enter, -1, enter. Now for row 2, same process, 2, enter, -4, enter, 1, enter. Fantastic. Row 3, -2, enter, 2, enter, -3, enter. Cool. So then you just confirm that we entered everything correctly. I think we did. And now we're gonna get out of the screen. So we're gonna put second, quit. Okay, second, quick. And we are gonna use our calculator to find the inverse. So let's go ahead. We want to enter A inverse. So give me a sec. We want to put A inverse equals, okay, what is the inverse of this matrix look like? Okay, so we want to recall matrix A. So again, matrix is not the main key, it's a behind key. So we're gonna do second matrix. So second matrix, and on the first tab names, we want to hit matrix A. So the cursor is already on matrix A. Let's go ahead, hit enter. Cool. But we want A inverse. Okay, so we gotta look for that inverse button. Where am I? It's the one that has x to the -1. Okay, so that's the notation for A inverse, kind of like how we have it on paper. And then we're just gonna hit enter, and it's like, oh my goodness, what's going on? So where should we round to? Nowhere. Okay, we only round when the directions say to round. So we're gonna go ahead and introduce a new button. So let's go, oh, maybe I think we've used it before. Let's go ahead, look for the fraction button. Okay, so we're gonna go to the math key. Okay, so it's underneath alpha, math. And then we want to hit the first option, which is fraction. I want to, let me enter it. Go ahead, hit enter. Okay, what is this saying? It says A and S, so it's taking our answer, and then triangle, it's like an arrow. So it says answer to fraction. So it's going to take our answer and it's going to convert it to a fraction. So it's going to give all the elements in fraction form. So we hit enter, and there we have nice fractions. So the inverse is also a 3 by 3 matrix. Okay, so let me go ahead, copy it. Okay, so the inverse is first row is, give me a sec, it's going to be 5/11, 2/11, -1/11. Row 2, we have 2 11s, -5 20-seconds, -3 20-seconds, and row 3, -2 11s, -3 11s, and -4 11s. Fantastic. And then we have to use our proper notation. The only way the reader is gonna know if this is a matrix is if we enclose these elements within the brackets. Okay, so done. Okay, problem B. So we have a matrix of size 2 rows 2 columns. It's a square matrix, so we do have a fighting chance to have an inverse. So I want to know what is the inverse. We're gonna use the same process. So let's go ahead, edit another matrix. So let's go back to our matrix menu. So second matrix. So second, and matrix again is not a main key. It's one of the behind keys. So we have to hit the second button first. Cool. And then we're in the matrix home page per se. So we want to edit, and then you can, I mean, I know it says matrix A equals, but you can, if you want to change it to matrix H, go for it. Okay, I usually edit just the first one. I edit the rest if I have more matrices to attack. Okay, so let's go ahead, use our side arrows to go to edit. We're already at matrix A, enter, and then the size is 2 by 2. And then enter the element. So it's going to be -2.5, 1, 5, -2. If you're good at texting, this will be really easy for you to punch in. Cool. We verified that we entered it correctly. Now let's go ahead, quit this page. Okay, so second quit. So we have second quit, which is not the main key, it's the behind key, which is mode. Second quit. and then let's go ahead clear this because it's in my way. Okay, so we want to use the calculator to find the inverse. So where am I? A. So we're gonna go ahead do second matrix. So we have second matrix. The matrix key is the behind key where we have x to the negative 1. Cool. And then we want to spit out matrix A. So it's already highlighted, so that's matrix A. I thought I hit enter, but I guess I didn't. But we want to find a inverse, so we're gonna hit the inverse key, which is that key that looks like x to the negative first, and then we're gonna hit enter. And I'm having a problem. So the screen says error, singular matrix, and then they give you a little disclaimer. It says no inverse matrix exists. Calculator result not found if dependent on the matrix inverse. Okay, pretty much what this is saying, singular matrix. Singular matrix, what does that mean? It's code for like the inverse doesn't exist. So the inverse, let me just write it out. The inverse does not exist. So in order for us to have a fighting chance to have an inverse, we need to make sure we are a square matrix, okay? But as you can see, the fact that we have a square matrix does not guarantee that the inverse exists. Sometimes it does, sometimes it doesn't. That's just life. Cool. So let's go ahead and wrap up this unit with these two fun problems. So we're going to go ahead and bust out our calculator again. It says use your graphing calculator to examine the product of matrices A and B to determine if each is the inverse of the other. So I want to know if A and B are inverses of one another. The question is, what has to hold true? To see if they're inverses, we have to verify that their product forwards and backwards both yield the identity. So let me go ahead and speak to myself. Verify that, I should say if, verify if the product one way equals the identity and the product backwards also equals the identity. Why do we have to find the product forwards and backwards? Well, the reason is because matrix multiplication is not commutative. I think I forgot to stress that in an earlier video, but it's not. For regular numbers, 2 times 3 is the same as 3 times 2, but matrix multiplication is not commutative. So we're gonna enter in our calculators A, B. So we want to use our calculator to verify what the product of A and B gives us. So we have two matrices, so let's go back to our matrix home page, okay, or matrix menu. So we're going to do second matrix, okay. So again, matrix is the behind key where we have x to the negative first. We're going to hover over to edit, and then we want to edit matrix A. We're already at matrix A, so we'll hit enter. Matrix A is a 2 by 2 matrix, so let's go ahead. Those are the same dimensions. Let's go ahead, put the elements. So 5, -7, -2, 3, enter. So we're done, but we have another matrix. This one is also a square matrix. Cool. So we're gonna, I don't think there's a back key, no. So we're gonna do again second matrix. So second matrix, and we want to edit matrix B. So we use our side arrows, and then we drop down. We're at matrix B. Cool. Enter. And we want it to be a 2 by 2 matrix. Fantastic. And then we edit it. So the elements are 3, 7, 2, 5. Cool. So let's come back home. So second quit, we want a clean screen. Cool. So we want to show the reader what the product of A and B gives us. Okay, so we're going to do second matrix, and we're going to put matrix A, and then we're going to multiply it by matrix B. So second matrix, and then we scroll down to B, enter. So in our calculator we have A times B. Okay, so we hit enter and we write down what the product gives us. This will be our work. Our work is writing down what the product of A and B gives us. Okay, so product of A and B gives us 1, 0, 0, 1. Now they are inverses if the product forwards and backwards will give us the identity. So the identity for a matrix of order 2 or 2 by 2 matrix is the matrix where we have ones on the diagonal and 0 elsewhere, and that's exactly what we have. So this gives us the identity, so we're good. But just because we have the identity going one way, that doesn't mean it's gonna hold true. We need to show both. I mean, come on, if we're not going to show the math by hand, at the very least, we can write down what we're asked, okay? So with our calculator, we want to show what the product of B and A is. Hopefully, it also gives us the identity. So we're going to do the same thing. So second matrix, matrix B, times second matrix, matrix A, and it also gives us the identity. So 1, 0, 0, 1. So the identity matrix for a square matrix of order 2, code for 2 by 2, is the matrix when we have ones on the diagonal and 0 elsewhere, and that's what we have. So we have shown to the reader that the product going one way and backwards gives us the identity matrix. So to answer the question, use your graphing calculator to examine the product of matrices A and B to determine if each is the inverse of the other. Yeah, they are. So I'm going to say yes, A and B. So matrix A and B are inverses. Where am I? Fantastic. Okay, yeah, I need to pay attention. Sorry, guys. Problem B. So I want to know, are these bad boy inverses of one another? So same speech. We need to verify that the product going forwards and backwards gives us the identity. So the first one is a 3 by 3 matrix, 3 rows, 3 columns. Matrix B also has 3 rows and 3 columns. Okay, so we have square matrices. Let's go ahead, edit matrix A and matrix B on our calculators and and see if their product gives us the identity forwards and backwards. So let me clear this because it's in my way. So let's go back to the matrix page. So we're going to do second matrix. So it's the, again, x to the -1 key. We want to edit matrix A. So we use our side arrows. We already have matrix A highlighted. So enter. The dimensions are 3 by 3. Go ahead, apply your texting skills to edit. So be 1, 0, -1, 3, 1, -1, and then 0 all the way. Cool, fantastic. So let's do the same thing, but edit matrix B. So second matrix, hover over to the edit tab, but we want to edit matrix B. So we use our cursor down, enter. We list the dimensions, which should be 3 by 3 because that's what we wrote. Again, apply your texting skills. So be 1, 0, -1, -3, 1, -2, 0, 0, and 1. Fantastic. So hopefully in my speed race I didn't make a mistake. Cool. So let's go ahead. Let's go to like the home screen. So second quit. Cool. And then let's see what the product of A and B gives us. So again, if we're not going to do the product by hand because the problem says use your calculator, hey, let's take advantage but still show some work. So we want to know if the product forwards and backwards will give us the identity. So one's along the diagonal, 0 elsewhere. Okay, so matrix second matrix, spit out matrix A times second matrix, spit out matrix B. And then we hit enter, crossing my fingers, and that does not look the identity matrix. So where is my special effect? So I'm going to write it out. But the identity matrix, we would have ones on the diagonal, zeros elsewhere. We have some ones on the diagonal, but not ones along the way. So let me go ahead, write down what we have. So product of A and B, according to our calculator, is 1, 0, -2, 0, 1, -6, 0, 0, 0. We have established that this is not the identity matrix, but I'm still going to highlight the diagonal. So unfortunately, we do not have ones along the diagonal and 0 elsewhere. This is not the identity matrix. So to answer the question, are A and B inverses of one another? The answer is no. No. A and B, matrix A and matrix B are not inverses. Now the question is, should we show the product of B and A? I mean, you can, but I wouldn't waste my time. if you get the identity for one product, yeah, you have to show the product backwards. But the moment that you realize that you don't get the identity one way, that's it. It's not they're not inverses. There's no need to show the product backwards and be like, yeah, they're not inverses again. Cool, fantastic. So that's my time. Thanks, guys.